This is 6.3 part 2. We're going to finish off the question over here, example number 2 that we had started. We had completed the square to find the vertex, and then we were asked to plot this graph here. And we saw there's different methods to do it. You can graph it by doing translations of y is equal to x squared. You could also plot the vertex and the y-intercept and then and use symmetry. To find the third point. And you could have done that with the zeros as well. You could have factored and everything. But if I only asked you to do this and not factor, well then you could have just used symmetry to find a third point. Let's just do the example with the y is equal to x squared first to show you how that would work out. So I'm going to draw y is equal to x squared. I'm just going to choose a few key points. We know that when y is equal to x squared, when x is equal to 0, the y is also 0. We know at 1, y is 1. We know at negative 1, y is 1. We know at 2, y is 4. And at negative 2, y is also 4. And you could find more points if you needed to, but right now this is good enough to sketch. This is our y is equal to x squared. And so if I had the point 0, 0, it's being translated to the left 3 units and down 7 units. So it'll go to negative 3 and then to negative 7 over here. Whoops, right about here. And then our point negative 1, 1 would go to negative 4 and then negative 2. Oops, sorry, that was wrong. Let me just erase that and retry it. So it would go to negative 4, 3 to the right, 7 down, so to negative 6 over here. Let's get the ink back there. And then this point here would go to negative 2 and then down 7, so to negative 6 over here. This point here, it's a 2, so it would go to 1, 2, 3, negative 1, and then it would go down to, so it's at 4, so down 7, so negative 3. And this point here would go 1, 2, 3 to the left, and then 7 down, so 4, and then 1, 2, 3, so negative 3 here. And then you could sketch by connecting these dots. And we have this equation over here plotted. You could have just plotted the vertex, found the y-intercept by plugging in 0 here, and you would have found that it would have been 2. I should say, that's right, 2. So when you put 0 in here, you have 9 minus 7, so that would be 2. You could have drawn your parabola so that it hits at 2. And then if you know that you're 2 when you're at 0, you could use your axis of symmetry to find where the other point would be where you're also at 2. So for example, if we're at 2 when you're at 0, and that's 1, 2, so that's 1, 2, 3 units away from the vertex, then 3 units away from the vertex on the other side would also be at 2. So 1, 2, 3, and then that should be at 2 as well, and you can connect the dots there too. You can test it out. So if you had negative 6 plus 3, that's negative 3 squared is 9, minus 7 is 2. So you could also use symmetry, because again, a parabola is symmetrical on both sides. So try to plot graphs in multiple ways. If I were you, I would redo this problem here by plotting the graph using the translation method, using the mapping rule, using zeros, using as many different ways as you can, just so you have all those tools available to you in the event that you're given information on a test, assessment, or quiz, and you don't have everything you need for one particular method, but you know other methods to use. So we're going to go and do example 3 now. So it's a word problem. Christopher threw a football its height h in meters after t seconds can be modeled by this equation here. What is the maximum height of the football, and when did it reach this height? So you've done questions like this before, where you have to find the vertex basically. So we want maximum height and when it reached this height. So in other words, we want our k and then our h over here. Now, I probably shouldn't be using these letters because we have h and t here. So in other words, our maximum height is represented by the letter h in this equation, and then our when is represented by the letter t in this equation. So we could try to factor. We could use our factor, find the zeros, and then find the middle, and then that'll be our axis of symmetry, which is our h value, and then we can find our k from there. We could use our quadratic formula as well to find your zeros and find the middle value and then find your k there. But now we know another technique. Now we can do complete the square. We can do complete the square to find the vertex. So it's the same idea. Don't be intimidated by the decimals there. H is equal to, we'll put our brackets around, negative 4.9 t squared plus 11.76 t, and then plus 1.4. Let's take out a common factor. So what we can actually do is we can take out the common factor, negative 4.9. So we'll have negative 4.9 taken out, constant factor. That leaves us with t squared. And then if we do 11.76 divided by negative 4.9, so 11.76 divided by negative 4.9, we get negative 2.4. So negative 2.4 t plus 1.4. We then need to find the term that would make this a perfect square. So 4.9 t squared minus 2.4 t. Remember, to find that term that makes it a perfect square, we do the b value, so negative 2.4 divided by 2, the whole thing squared, which would be negative 1.2 squared, which is, so let's do negative 1.2 squared, 1.44. It's like 12 squared is 144, but just a factor of 100 less. So 2.4t plus 1.44 minus 1.44 plus 1.4 over here. Now we're going to take this out and multiply it by a as we do so. So we get h is equal to negative 4.9 t squared minus 2.4 t plus 1.44. And then the negative 1.44 times negative 4.9 gives us plus 7.056 plus 1.4. And then we can factor with our perfect square there. So negative 4.9 brackets t squared. There's a negative sign here, so that means this will be negative. And then the square root of 1.44 is 1.2. And then 7.056 plus 1.4 is plus 8.456. So we've completed the square, and we've confined our vertex. Our vertex HK is 1.2 and 8.456. So what that means from this, when we interpret this problem, we write a therefore statement. Therefore, the max height of 8.456 meters is reached at 1.2 seconds. So we have the height and we have the time, the when. And again, we didn't have to do our factoring, we didn't have to use our quadratic formula and use symmetry to find the axis of symmetry. All we had to do was complete the square, find our vertex, and the equation was completed that way. Much simpler than the other methods. But it doesn't hurt to know the other methods as well. Okay, we're going to start off this next question. We might not have time to finish it in this video, but at least we'll get it started. So a gardener wants to enclose a rectangular, so that's important here, rectangular. A lot of you are making square ones. Rectangular vegetable garden with 60 concrete curbstones, each 1 meter long. What are the dimensions of the maximum area the garden can enclose? So first, write expressions for both perimeter and area, and then isolate one of the variables in the perimeter formula and substitute it into the area formula, expand and simplify your new formula. So let's go take a look at this. So we know that the perimeter is going to be 60 times 1 meter. So our perimeter is going to be 60 meters. And we know it's a rectangle with a length and a width. And what we know for sure is that when you add all the sides up, so perimeter is going to be equal to 2L plus 2W, that's going to be equal to 60. So 2L plus 2W is equal to 60. And this is equation, let's call it 1. And equation 2 will be our surface area equation. Area is equal to length times width. We are looking for the maximum area that the garden can enclose. So what we're going to do is we're going to isolate one of the variables, either L or W, it doesn't really matter. Let's choose to do W. So we're going to have 2W is equal to 60 minus 2L. We're going to do the inverse operation to isolate W, so divide by 2 there, and we get W is equal to 30 minus L. And so this will be equation number 3. And now what we can do is we can sub 3 into 2. And so we're going to get area is equal to, so we have L times 30 minus L. And we can distribute that to get area is equal to 30L minus L squared. Or you can rewrite it as area is equal to minus L squared plus 30L. And so let's see what our next question is. Our next step is complete the square to determine the maximum total area and the dimensions needed to attain this area. So in other words, we need to find our vertex. We don't need to factor now. We can just use this here to find the vertex to give us our maximum, to give us our maximum area for the maximum length that's provided there. So we'll start that off. So again, we have our equation A is equal to negative L squared plus 30L. We won't have time to finish this in this video, but we'll finish it in the next one. So we don't have a plus C. We actually do. It's plus 0. We don't need to write it. So we'll continue the next step in part 3 of this video.